Okay, this is my written explanation for question 9. So I chose the sequence just from 0 to 2, 1, 2, 3, and then the impulse is shown right here at n minus 2, and that's just like an impulse shifted to the right too. If you make n negative, you essentially reflect it on the y-axis, and you get an impulse at negative 2. And this is the definition of the flip and drag method, and we'll kind of use that to illustrate what's happening here graphically. And switch. Okay. So seen up here, seen up here, if we use this graphical method, we can think of it as like um, the impulse being at negative 2. There are no x values that are defined anything other than 0 at negative 2. So we could think of that impulse being multiplied by 0 there, and just everything results as 0. And we could kind of see from this definition that and the only time this impulse is valid is that k is negative 2 and x of negative 2 is just is 0. There's nothing there. And there's nothing there until we get to when n is 2, because then we have this impulse function 2 minus k minus 2. So we have an impulse that's valid at 0 or k equals 0. And that's where x has started to be defined. So x is 0 is just 1. So we just multiply 1 by 1 this impulse here. And similarly for um, these next values, which is 2 and 3, we get this function. I didn't show it here, but um, the convolution would just be kind of the sum and the superposition of all these points. We have 1, 2, and 3 that starts at 2, ends at 4. So we could see clearly that it's just shifted to the right by 2.